Okay, in this session, I will introduce you, or I will show you the solutions. I will give you the solutions for the problems that were given in the exam. So, first problem was question number 6. So, you were asked to give minimize DFA for A star, B star, B. And so first of all, like as per the mark division we discussed earlier, like we have to first draw an NFA. Okay, so this is A, this is A star, this is B, this is B star, then we have plus, so this conjugate plus. Okay, so let us give arrows. And we have A here, so this is A, this is connection, this is initial state, this is B, and so now when we do see this case, rather considering these solutions, we'll give names to this. So this is A, this is A, this is B, this is B, epsilon, 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 epsilon. And so let us give numbers. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13. Fine. So first of all, what we need is we need to compute epsilon closure of initial state. So what is epsilon closure of initial state? 0. So it would be 0 only. Correct. Now when we see this 0, we'll give name to this as A. Mark A. And with this state for A, T is 1. For B, T is 5. So epsilon closure of T would be now 1 epsilon closure 1, 2, 3, 7, then 10, then 6, then 11, then 12. So include 1, 2, 3, then 6, then 7. Sorry, we missed 4, 3, 4, 6, 7. Okay, then 8, then 10, and 11, 12. Fine. So this is not going to be there. So this will give name as B. So mark B equal to 1, 2, 3, 4, 6, 7, 8, 10, 11, 12. For A, calculate T. So we can see 1 is there, 2 is there, 4 is there. So we can include 5. There is nothing other than this. So this will be done. So epsilon closure of 5 is 4, 5, 6, 11, 12. 4, 5, 6, 11, 12. For B, T equal to, now we may see here we have 8, that's why 9. We have 12, correct here. So that's why 13. So epsilon closure of T is 8, 9, 10, 11, 12 and 13. So this is C, this is D. Correct. Now we already marked A and B. Mark C. So for A, this is what? 4, 5, 6, 11, 12. For A, T is 5. Correct. And there is nothing. So this is self loop. And for B, T. So if we see this 4, 5, 6, 11, 12, we have only 13. This is epsilon closure of T is 13. So that's why it is E. So mark D for A, T equal to. So this is 8, 9, 10, 11, 12, 13. It is 5. For B, T is, as 8 is there, so 9. And then 12 is there, that's why 13. So 9 and 13 we already saw it is self loop. Correct. Now remaining is, let us mark E. E is 13. So there is no transition for A, 5. For B, 5. So let us draw the DFA. So we got this A, B, C, D and E. As 13 was final, so we can see D and E are containing final state. That's why both of them will be acting as final. So this is it. For A, we got this B. There is no B transition. From B with A, we went here. Then this is B. From C, there was self loop with A, and for B, it is going here. Fine. And for E, there is no transition, but for D, we can see there is a self loop for B. So this was your solution for DFA. Now we have to apply minimization procedure. So let us divide this into two groups, non-final first and then final later. Fine. So now we see that from B with D it is going outside, and from C also it is going outside. So we will take them away together. Why? Because for A they are going to C, and for B they are going to same group. That's why we grouped them together, and we have now DE. Now B and C, if we see, both of them, for A they are remaining in same group, but for other thing they are going to other group. But if I now talk about this DE, there is only one transition for D and there is no transition for A. So even we cannot keep them in the same group, so we have to divide them. So we will have A, B, C, D and E. Now if we come back and see, from B it is going to D and for C it is going to E. So that's why this would be A, B, C, D, E. Now this results to what? We cannot further optimize this. Whatever the DFA that we got earlier is the final solution. Okay, so this is the minimized DFA only. Fine. So this is your first problem. Second problem was with respect to construction of regular expression for the given diagram. So we will have NFA given as A. So I gave name as 0, 1. So let us take the same thing. 0, 1, 2, and we have 3. So this is double thing. This is A comma B. This was A comma B. This was A. This was B. This was B. This is A. And you have initial state. So first of all, we have to write equations for the each of the state. So how many incoming transitions are there for 0? So 2. So we'll write 0A plus 0B, state name and then input, plus as it is initial state, so we'll add epsilon. So for 1, there is only one transition, so it is 0A. For 2, there is only one transition, 0B. For 3, it is 1A plus 2B plus 3A plus 3B. We may see here this is like as per regular expression, Arden's theorem. So if we take common 0, we have A plus B plus epsilon. So this is in the similar form, R equal to Q plus RP. So we will write this as A plus B star. Fine. So 0 is replaced by A plus B star. So ultimately 1 becomes what? A plus B star A, correct? And 2 becomes A plus B star B. Now we have to put this into 3. So we'll write 1 A. So A plus B star A and this A plus A plus B star B plus this B, plus we will take 3 common, A plus B. Fine. Now if we see this, we can take further common, A plus B star A plus BB plus 3 A plus B. So it is now again R equal to this to be Q plus this to be R and this to be P. So equation for this would be A plus B star AA plus BB A plus B star. Okay, so this would be your final solution. Fine.